Section 1.5 is modeling with linear functions. So what we're going to do is look at taking real-world situations and how we can model them using a linear function. We're going to start out by looking at this example. We have 4 different towns, and each town has a different population associated with it, and it's given by these functions here. So town A, for example, is 20,000 plus 1,600 t. All right, our first question is, which of the populations are represented by linear functions? So linear functions, probably the most common form of those that we see is something that looks like y is equal to mx plus b. Right, that would be our slope-intercept form. You could certainly look at this from a point-slope form as well, but this is kind of the most common way that they're written. And so if we look at these, this one has a number attached to t, and then plus a constant. So town A is linear. Town B, so we have a negative 300 t, so we have a constant attached to our variable t, and then adding this other number here, this 50,000, so B is also linear. C, so here I have 15,000 multiplied by 1.07 raised to the t. So that t being up in the exponent, that means that this is not linear. So this one is going to be actually exponential. And we'll take a look at those in chapter 4, but this one is definitely not linear. And then letter D, so here I have a constant times t, my variable, plus another constant. So D is also going to be linear. All right, part B, describe in words what each linear model tells you about that town's population. And specifically what we're looking for is the starting or initial population, and then how the population is changing each year. Okay, so all right, let's make a little kind of table here out of this. On the side, I'm going to put the initial or the starting population. And then the grows or changes by as kind of a second row. And so we'll go through and identify that for each of these linear ones. So our initial population is the population at time 0, and that's going to correspond to this y-intercept that's represented by B. So in the first town, our population is 20,000 to start. Okay. And then it grows, so by 1,600. So this is actually going to increase each time by 1,600 people. And that's really what our slope is representing there. So town B, the 5,000 is by itself. So that is or 50,000, sorry, is our starting population. And then our slope here is negative 300. So our population is actually decreasing by 300 each year, since that is a negative 300. And then we decided that letter C was exponential, but it does turn out that this number that's here on its own is going to be their initial population. So that's going to be about 15,000. Okay, and then that slope part we haven't got to that yet. We'll look at that at chapter 4. And then the last one, so the number by itself is this 45,000. So starting population of 45,000. And then this one has a positive slope. Our M is 650, so it is increasing by 650 people per year. All right, so that kind of gives us the details for each of those 4 towns. And then part C says which function goes with which graph. So these 3 are all lines, so we know that these are going to be matched to our linear ones. So these are A, B, and D. That means that this one over here is population C. That's what an exponential curve looks like. Starts out with maybe some slow growth and then starts going faster. And then we have these 3. So there's a couple different ways we could look at how to match these up. The first is we could match these up by just using our initial population, which is our y-intercept. So we have a 20,000, a 45,000, and a 50,000. So we can match them just based on those, which would make this one the town A as an apple. This next dot up would be town D as in dog. And then this top point here, that is going to be town B as in ball. Okay, so that's one way we could do it. Another way we could look at figuring these out is I have two that are going uphill. So I have two with increasing, and I have one that is decreasing. The only one with the negative slope was town B. So that'd be another way. And then between these two, because they're both positive, I'm looking for the one that has this steeper slope because it's going to be growing faster. And so then I can match these up. This one looks like it's growing a little steeper. And that 1600 is bigger than the 650. These are only two positive ones. So that would tell me that this is A, and that makes this one D because it's not growing quite as fast. All right, of the towns that grow linearly, so out of these three, which one starts out with the most people? So here's our starting population, and the most people is this one with 50,000. So that would be town B, as in boy. And then which one is growing the fastest? So we can actually eliminate this one because it's not growing, it's shrinking. And then we talked about this a second ago, but the one that's growing the fastest is the steeper line or the bigger positive slope. So that would make this town A.